Question number 3. This is about coordinate geometry. Now, let's see. We have the point P, point Q, point R and O, and this show that parallel line. So let's read the question and understand. The diagram above shows a trapezium OPQR. The line OP is perpendicular to line PQ. PEQ is a straight line such that point E lies on x-axis. It is given the equation of OP is y equal to negative 2 over 3x, and the equation PQ is 2y equal to 3x minus 26. So from the line OP, we can write gradient of OP is negative 2 over 3 because y equal to mx plus c. There's a negative there. For equation of PQ, the y is, we always want the y alone as a subject. So we divide by 2, divide by 2, divide by 2, t over 2x minus 13. So what we want is the gradient for PQ, and PQ is t over 2. Right, the question say OP is perpendicular to OQ. That means this one, these two gradient, one of them is M1, one of them is M2. It should be follow the rule perpendicular gradient. When multiply, the product of the gradient must be negative 1. So we take t over 2 times with the negative 2 over 3 is equal to negative 1. So hence we can find the value of the t. So this one will simplify negative 1. So negative 1, alright, negative 3 times negative 1, so the t will be 3, right? So the value of t is equal to 3 by using the concept of the gradient. Now we need to find the coordinate of point P. Where is the point P? Point P is here, is the intersection between the line, between which line? Between the green line and the red line. So when we see intersection point, we will use simultaneous equation to find the point of intersection. Remember, this is a concept that you must know. So we need the equation of PQ, we need the equation of OP. So this is equation number 1. Equation number 2, then we solve it simultaneously. Now let's solve it simultaneously. So in order to find the point P, we will take this equation, and this equation, and then we will solve. Alright, so we have the, okay, so let's write down. So we have the equation for the PQ is, let's write y equal to this one. I'm going to use this one. T is 3. PQ equal to 3 over 2 x minus 13. And we have the line just now was line OP, this one, right? OP will be negative 2 over 3x. Okay, for line OP, this is y, okay? Y equal to 2 over negative 2 over 3x, negative 2 over 3x. So this one and this one we will solve, right? So we will write, we will make it equal because of the intersection. So 3 over 2x minus 13 equal to negative 2 over 3x, right? So let's solve it now. We have 3 over 2x plus 2 over 3x equal to 13. So we can always times 2 times 2 times 2, here times 3, here times 3. So we have, let's see, we have this one is times 3 is 9. We have 9 over 6 x. This one times 2 will be 4 over 6, right? Equal to 13. So we have 13x. Come, I write here. We have 13x. Okay, we have 13x here. I'm going to write down the 13x over 16 equal to 13. So that means x is 6, right? So how to find the y? Of course, we will substitute into any one of these. I can use this. So I just substitute 6 here. So my y will be here 2, negative 4, right? So we can find the x is 6 and y is negative 2 over 3 times 6, so is negative 4. So that means the point of intersection is at 6, negative 4. Alright, so that is the point P. Okay, we have solved the point of intersection. Remember what I say, intersection means simultaneous. Okay, settle the simultaneous equation to find the intersection point. Now, PE ratio to EQ is 2:1. Find the coordinate of Q. PE, where is PE? Let's clear the space. We are going to write the ratio. Okay, PE. There is a point here, let's say PE, EQ. The ratio was given, right? So let's read the question again. PE is 2, EQ is 1. So that means PE is further a bit. Now let's see. Let's say here E is lies on x-axis. If I not okay, here just now I read through, E lies on x-axis. Okay, I put an E here. This ratio is 2, this is 1. Now we have the point P already, right? 6, negative 4. Now the point Q. How to find the point Q? Point Q, let's see, the question gave find the coordinate point Q. Alright. Okay, so we have the point E lies on the x-axis. Obviously this will be 0. And the equation of PQ was given. So you can find the x here. This x can be found. Then after that you can find this point. Alright, so let's say this point I solve first. Okay, I have the equation y equal to, equation for PQ is, equation for the PQ is this one. 2y equal to 3x minus 26, right? This equation, I'm going to substitute my y 0, 2 times 0, y, because at the point E it is 0, the y coordinate. So x is 26 over 3. It's okay, we have 26 over 3, it is a fraction. So x is 26 over 3, right? So with that, we can find the point Q. Let me do like that. Okay, I'm going to draw horizontally. This is point E, 26 over 3, 0. This point is x, y is not given. This point is 6, negative 4. And the ratio here is 2, 1. Now I'm going to cross it. 2 times x. And then 1 times with the 6 here is equal to this, right? So let's get it solved. Okay, we are going to solve the point now. So 26 over 3 is equal to 2 times x plus 1 times 6 over 2 plus 1. Alright, so we can solve it easily because this one 3, so 26 is 2x plus 6. So 2x equal to 20, right? So x is 10. So we found out the x here is 10. This one just now we got ready, this one we got ready, right? This is 26 over 3, this is 0. And the point P we have 6, negative 4. Okay, after that we can use, in fact we can use the equation y equal to, or we can use the ratio theorem. Just now we have the equation is let me see, the equation is 3 over 2x minus 26, 3 over 2x minus 26 over 2 minus 13. So I can substitute the 10 inside to find the y easily. 15, so 15 minus 3 is 2, right? So the y is 2. Or else you can do like just now, you can use a ratio theorem, but it's just that you have to use a y. That means instead of use 26, I will use a 0 here. 0 is equal to 1 times with a negative 4. 1 times with a negative 4 plus 2 times with a y over 3. So 2y is equal to 4. Y is 2 also. So I'm getting y equal to 2. Even though I use a ratio theorem or I use a equation, because I have the x, I substitute, I will get a y equal to 2 also. There are many ways to do. So that's point Q. Solve already. We have solved the point Q. Now, what is the equation of straight line QR? Okay, QR, where is the QR? QR is here. This is a perpendicular, right? So let me show how to find the equation which is perpendicular. So we have the M here. We have the point Q, which is 10, 2. We need a gradient to form the equation. We need gradient and the point. So this one is just now we have the 3 over 2, right? The gradient for this line, PQ, for the blue line, and then for the red line, this one. I'm going to show you this one. The M here should be negative 2 over 3. Why? Because these two gradient must be negative 1 when you multiply. So we just inverse, and if this is positive, we will make it negative, right? So we can use y equal to mx plus c. M is negative 2 over 3, x is 10 plus c. C will be 2. So we have negative 20 over 3 plus c. So that means c will be, let me solve it here, negative 20 over 3 plus c. 2 plus 20 over 3. So I have 26 over 3, right? C. So then I substitute into here. Alright, so my equation will be y equal to negative 2 over 3x plus 26 over 3. This is the equation in gradient form. If you want to write the equation in this way, you times 3 also accepted. So either one. So the equation for the QR is 3y equal to negative 2x plus 26. Using the m1 times m2 equal to negative 1. That's all my sharing about question number 3. Bye bye and have a nice day.